massive increases in compute, massive increases in energy, expensive energy, manufacturing scale. What are the bottlenecks to get there? And that, once again, with all that expenditures, again, how can we make sure that it's broad and not narrow?
I just think the natural thing is it's going to be very broad because AI companies will seek as many customers as they possibly can, and the cost of AI is already very low, and it's plummeting every year. I mean, the cost of AI is almost meaningfully changing on a month-to-month basis.
There's open models now everywhere. Yeah.
Yes, there's open models, and the open models only lag. They're maybe a year behind.
Right.
The sort of closed models. So I think the AI companies will seek as many customers as possible, which means they'll provide AI to the world.
But the cost of getting to there, the compute, the chips, the fab, the powering, that to me, what are the those are huge.
The limiting factor, yeah, I think the limiting factor for AI deployment is fundamentally electrical power.
It's just, right, it's energy.
Yeah. I mean, we're seeing the rate of AI chip production increase exponentially, but the rate of electricity being brought online is
3%, 4% a year,
yeah.
max.
Yeah. It's clear that we're very soon, maybe even later this year, we'll be producing more chips than we can turn on. Except for China. China's growth in electricity is tremendous.
They're building 100 gigawatts of nuclear as we speak.
Actually, solar is the biggest thing in China. So I believe China's production capacity on solar is 1,500 gigawatts a year, and they're deploying over 1,000 gigawatts a year of solar. Now, for continuous solar load, you divide that by roughly, I don't know, 4 or 5. Call it that's around 250 gigawatts of steady state power paired with batteries. And that's a very big number. That's half of the average power usage in the US.
Right.
So US power usage on average is 500 gigawatts. Right. China, just in solar, just in solar that can provide steady state power, and batteries can do half of the US electricity output per year just with solar. Solar is by far the biggest source of energy. And actually, when you look beyond, or even on Earth, but certainly beyond Earth, the sun rounds up to 100% of all energy. This is an important thing to consider. So the sun is 99.8% of the mass of the solar system. Jupiter is about 0.1%, and everything else is miscellaneous. Now, even if you were to burn Jupiter in a thermonuclear reactor, the amount of energy produced by the sun would still round up to 100%, because Jupiter is only 0.1%. If you teleported 3 more Jupiters into our solar system, and burnt 3 more Jupiters and everything else in the solar system, the sun's energy would still round up to 100%. Mm-hmm. So it's really all about the sun. And that's why one of the things we'll be doing with SpaceX within a few years is launching solar-powered AI satellites.
Right.
Because the space is really the source of immense power, and then you don't need to take up any room on Earth. There's so much room in space, and you can scale to enormous. I mean, you can scale to, I think, ultimately hundreds of terawatts a year.
You and I have had these conversations before, but why don't you tell the audience what would it take for the United States, and what type of geography would it take to have that solar field to electrify the United States? And then let me ask a question, why aren't we doing it?
Yeah, so, I mean, I guess a rough way to think about it is 100 miles by 100 miles, or call it, I don't know, 160 kilometers by 160 kilometers of solar is enough to power the entire United States. So the 100 mile by 100 mile area is, I mean, you could take basically a small corner of Utah, Nevada, New Mexico. Obviously, you wouldn't want it all in one place, but it is a very small percentage of the area of the U.S. to generate all of the electricity that the U.S. uses. And the same is true, actually, I mean, for Europe. You could take a small part, you could take relatively unpopulated areas of, say, Spain and Sicily, and generate all of the electricity power that Europe needs.
So why don't you think that there's a movement towards that here and in the United States?
Well, there is.
As it is in China.
Well, unfortunately, in the U.S., the tariff barriers for solar are extremely high, and that makes the economics of deploying solar so artificially high, because China makes almost all the solar,
What would it take for Europe or the U.S. to build it commercially, if it's that scale?
Yeah, I think. Well, I can tell you what we're going to do. You know, SpaceX and Tesla is we're building up large-scale solar.
Right.
So the SpaceX and Tesla teams both separately are working to build to 100 gigawatts a year of solar power in the U.S., of manufactured solar power. That'll probably take us, I don't know, about 3 years or something. But these are pretty big numbers. Mm-hmm. You know, I'd encourage others to do the same. We obviously don't control the, you know, U.S. Tariff policy, mm-hmm. But for other countries, I would recommend, you know, that China makes solar cells that are incredibly low cost, and I think it would be worth doing large-scale solar.
So I know you're going to be having a couple of big announcements on robotics and what it can do. I mean, when I went to the factory, you showed me those robots.
Yeah.
How quickly, you talked about the billions of robots, but how quickly can they be deployed in a manufacturing setting? How quickly can they be utilized and be functional and create that abundance that you talked about?
Well, humanoid robotics will advance very quickly. I think we do have some of the Tesla Optimus robots doing simple tasks in the factory. We expect probably later this year. By the end of this year, I think they'll be doing more complex tasks, but still deployed in an industrial environment. And probably sometime next year, I'd say that by the end of next year, I think would be selling humanoid robots to the public. That's when we are confident that it's very high reliability, very high safety, and the range of functionality is also very high. You can basically ask it to do anything you'd like.
You're already seeing that in Tesla cars. The software changes that you're doing, and what is it? Yeah. Every quarter now, a software change that upgrades the ability of the robot within the car.
Yes, the Tesla Full Self-Driving software, we update it sometimes once a week. Recently, some of the insurance companies have said that it is actually so safe, when Tesla Full Self-Driving is so safe that they're offering customers half-price insurance if they use Tesla Full Self-Driving in their car.
And that can be monitored by the insurance company? Is that part of the agreement then?
Yeah. I think self-driving cars is essentially a solved problem at this point.
Right.
And Tesla's rolled out a sort of robo-taxi service in a few cities, and
right.
will be very, very widespread by the end of this year within the U.S. And then we hope to get supervised full self-driving approval in Europe, hopefully next month.
Really that quickly?
Yeah, and then maybe a similar timing for China, hopefully.
I want to move to space because historically space is very capital intensive. It historically been done by governments. Obviously, SpaceX changed the whole model. But we've seen it slow to scale, and now I'm starting to see it ramping up in what you're doing and other things. Talk to us about the automation and AI, how it's changing the economics in building and preparing for us in operating in space.
Sure. Well, the key breakthrough the major breakthrough that SpaceX is hoping to achieve this year is full reusability. So no one has ever achieved full reusability of a rocket, which is very important for the cost of access to space. We've achieved partial reusability with Falcon 9 by landing the boost stage. We've now landed the boost stage over 500 times. But we have to throw away the upper stage. The upper stage sort of burns up on reentry for Falcon 9. So, and the cost of that is equivalent to a small to medium-sized jet. So, but with Starship, which is a giant rocket, it's the largest flying machine ever made.
That's a rocket that you're using for the idea of going to Mars, right?
Yeah, Mars and the Moon, as well as for high-volume satellite stuff. So, Starship. Hopefully this year we should prove full reusability for Starship, which will be a profound invention because the cost of access to space will drop by a factor of 100 when you achieve full reusability.
Right.
It's the same sort of economic difference that you would expect between, say, a reusable aircraft and a non-reusable aircraft. Like if you have to throw your aircraft away after every flight, that would be a very expensive flight. But if you only have to refuel, then it's the cost of the fuel. And so that's really the fundamental breakthrough that gets the cost of access to space, we think, below the cost of freight on aircraft. So, under $100 a pound type of thing easily. Wow. So it makes putting large satellites into space very low, very cheap. And then when you have solar in space, you get 5 times more effectiventive, maybe even more than that, than solar on the ground, because it's always sunny.
It's cold. And
It's always sunny, so you don't have a day-night cycle or seasonality
right.
or weather.